Yo, what's going on today, guys? It's your boy Zazo, and I'm back again for another video. So in this video, we'll be going over another LeetCode problem. We will be walking through this one. And remember, the important thing is to find out what's going on behind the code rather than just copying the code, memorizing the code, and then being able to basically regurgitate it from memory and use it on an interview or whenever you're trying to use it. What we want to really understand is what's going on behind the scenes. It's going to make us better. It's going to make us be able to solve these problems in a bunch of different ways. Even these solutions that I'm giving and these solutions that I'm essentially, explaining aren't the only solutions to these problems. This is just one way that I'm going about it and how I really internalize the information, and I'm trying to pass that to you guys so you guys can really learn how these things work so you guys can be better developers and engineers. All right, so let's get into it. I'm gonna go ahead and read this problem. I started recording and my mic was muted, so this is the second take. All right, remove duplicates from sorted array. Given an integer array nums sorted in non-decreasing order, remove the duplicates in place such that each unique element appears only once. The relative order of the elements should be kept the same, then return the number of unique elements in nums. Consider the number of unique elements of nums to be k. To be accepted, you need the following things. Change the array nums such that the first k elements of nums contains the unique elements in the order they were present in nums initially. The remaining elements of nums are not important, as well as the size. Return k. All right, so this is essentially the last problem that we've done. If you don't know about that one, go ahead. I'm pretty sure you'll be able to find it easily. But I'm going through these problems. So the last one we did was just a easier variation of this, I guess you'd say, or simpler version. This one right here, it looks like the difference will be unique elements, right? So whereas the other one, we could have the same element, we were removing a specific value of elements. So we're removing that value, where this one is, we are just uniquing the nums array. Uniquing, is that a word? Don't know, but I love it. All right, so as you can see here, we're given 1, 1, 2 as an array. We get output 2 because we're removing this duplicate of 1. And then we have this one right here, which, as you can see, you have a 0, you have a 1, you have a 2, you have a 3, you have a 4. All unique elements. And we were returning k, essentially, how many things are in the array, integers are in the array. So we're going to go over to the whiteboard. I'm going to attempt to talk this through, right? This is not on the, what's it called? This is not actually on the, this is an example. Usually I would like to start with an example, but to be honest, these two examples right here, one is too small, and then one is just like outrageously outrageous, and I don't want to write all that. So I just made up an array, because obviously it doesn't matter. You're supposed to be able to do this either way. So what we're essentially going to be doing here is we are going to be comparing essentially we're going to be comparing two of these elements, and we're going to see if they are essentially unique. I mean, I don't know how else I'm going to say that. So what we're going to need is we're going to need our slow pointer the same way we would last time, right? And then we're going to have a fast pointer, or, that's the one that goes through our array, essentially, right? So that's going to be J. I use these, just because they are a standard. I don't know. They're just kind of like used widely. So I'm just going to go with that. All right. So what we're going to do is essentially what we'll need to do is, like last time we started at, and we compared a value to a specific thing, a specific integer in the array, a specific element. We're essentially going to need to, because of how they're ordered, as you can see, right? They're ordered in non-decreasing order, which means that essentially the element before, so these two adjacent elements essentially we would be able to check if those two adjacent elements are unique. Therefore, if we can do that, we can get out all the unique elements. All right, let me show you what I mean. So what we're going to need to do is we're going to, in this, essentially need to come here. We'll basically put this as our fast pointer, and we will look at these two and continue to compare. Essentially, that's what we're going to do. We're going to compare this to this. How are we going to compare this? Right here, I is the slow pointer. J is going to be the fast pointer. So let's just start here, right? And look at, essentially this will be J. We'll start at J1. So this is where it's going to be a little bit different. J1. What am I saying? Index 1. J is going to be index 1. And then we're going to compare it to our slow pointer, which is 0. So, and then we'll do some logic. If they're the same, obviously do nothing. If they're not equal to each other, if they're unique, then we're going to want to increment. So that's essentially what I have in my head. So we're going to compare these two. If they're the same, do nothing and essentially move on, right? We're going to go through the next part of the loop, right? And then we're going to compare these two. Are they unique? So on and so forth. And we're going to go down the array. All right, that didn't make too much sense, but maybe if I code it out, we'll kind of get to something and then it'll make a little bit more sense. So let's go ahead and get into it. Any slow pointer, we'll call him I. We always call him I equal to 0. Now we're going to need our for loop, right? It's really the same, almost the same setup as we had in the last one for J in. Now this is going to be a little bit different because we're not starting here. We're not comparing it to the last one we had like val or whatever. We're going to be comparing it to adjacent item. So we want to set this one to range, which is just how many times are we going to loop. Where are we starting from? So we're starting from index 1, right? Index 1 is going to be here, even though it's 1. Index 1, right? Because that's 0. Until the end of the array. Nums, right? All right. So this is where we're going to start. I need my there and there. So we already got this set up to where we're comparing this with J, right? And this with I. So we're comparing adjacent elements. All right. I don't know what that was. Take that out. Okay. So as we're comparing, we want to check if J is not equal to, so we want to check if J is not equal to essentially nums I. All right. So if nums J, okay, we're returning K, is not equal to nums I. So if that is not the case, what do we want to do? We want to actually move on because they're unique, right? All right. So then we will increment. What am I doing? Is that it? Did my syntax? All right. So if they are not the same, we are going to go on. And then we also want to copy those elements back into the original array. So we're going to do like this, nums I, so which is the front, right? Or nums I, the first iteration will be 0. And we want to copy it back into, there you go, nums I. We want to take nums J. So if it's not equal to the other one, aka if it's unique, right? This one doesn't make sense. So we'll move down here. Let's just say I is down here because we're always doing adjacent items. So we'll scratch that out right now. But if we're comparing these two, or let's say this one's J, bruh, that's the same example. Scratch that too. I'm all over the place. I'm trying to, it's right here and I'm trying to explain it, but I'm moving too fast. And I want you guys to really get this. So let's say we're comparing these two. This is J, right? This is a bad example too, but we're going to go with it. This is J. So if these are unique, what do we want to do? We want to increment I. That means we want to move forward. Obviously, this doesn't make sense because we don't have another element here, but we want to go forward because they're unique. We don't need to do anything if they're unique. We need to move to find things that aren't unique so we can remove them. All right, that was a little bit of a cluster right there on my screen. But, and then, simple, we will just return I plus 1. All right, so this is a very cluster right here. This is clustery McClusterton. I'm just going to delete it all. And we're going to go through it again. It usually makes more sense as I go through. I'm pretty sure this is the answer. And I'm going to be honest, the last problem actually helped me solve this one. Now, keep in mind, I'm not saying that I'm solving this on the spot right now. I'm going through internalizing, understanding how to visualize this for you guys to really kind of embed this into your mind. So if I was doing this on the fly, we'd probably be here for like 20 minutes of me trying to figure this out. And I don't think that's really productive for like some of these things. I mean, it can be, but that's what you're supposed to be doing before you're looking at the answers. You're supposed to be going through having these tough times and trying stuff out essentially. So let me just make up a random situation here. Here. The good thing about this, now another thing of complexity would be added if they weren't in non-decreasing order, if they were just random things, because then we'd have to get a little bit more fancy. All right, but since they are, essentially what I'm doing, this is kind of like the happy path, assuming all items are unique, just to show you how the algorithm actually will flow through. So we have I at first, which is going to be here, and J, which is going to be here. We're going to compare these two. If these two are unique, right? We increment this, this becomes 1, and J moves over here now, right? So now we're going to be comparing 2 and 3. And these are also unique. So we're going to move forward, and this is going to increment, but as you can see, as we get through this, and let's say we do it again, 3, let's say we do it again, 4. We don't have 4 elements, we have 5 elements. So that is going to be why we return I plus 1. It is our slow pointer, so it's always behind 1 essentially. J is the adjacent item. This might have not made the most sense, but if you have any questions, leave them in the comments. Like the video, subscribe to the channel. I'll be coming out with more of these. I'm trying to break them down in a digestible way to where you guys can understand these algorithms and understand kind of how to set these up and what it looks like in code, and also what it just looks like kind of iterating through behind the scenes, which I think is the most important part about this. So go ahead and like the video, subscribe to the channel. If you're new, go ahead and leave me a comment. If you're not new, also leave me a comment. Love, peace, and chicken grease. I'll see you on the next one.